6 swappable modules, a 2mm gap, and 0 phones ever shipped. Break time equals 0. 6 is slash that combination killed Project Ara. It was the most hyped phone of 2013 to 2016. The one you could watch, cheer for, and never actually buy. The pitch was irresistible. Buy one phone, then upgrade it one piece at a time. Swap in a better camera, add a bigger battery, crack the screen, replace just that module, not the whole phone. It promised to end forced upgrades and cut e-waste, to do for hardware what apps did for software. And Google put real money and a public countdown behind it. Start at the beginning. In 2013, a designer named Dave Hackins posted a concept video called Phone Blocks, a phone made of detachable blocks. It went viral, tens of millions of views. Inside Motorola, a research group called ATAP, led by Paul Eremenko, was already chasing the same idea and adopted it as Project Ara. Here's the architecture they landed on. Picture a skeleton, a flat frame with a grid of slots, which they called the endoskeleton. Every function of the phone lives on a separate tile that drops into a slot. Processor here, screen there, camera, battery, speaker. What holds those tiles down? Not screws, not glue. Tiny magnets that can switch their grip on and off with a pulse of electricity. Turn them on, the module locks. Pulse them again, it releases. And the promise on stage was aggressive. Developer editions were coming. A public pilot would launch in Puerto Rico. The base model, a bare frame they nicknamed the Gray Phone, would start around $50, and you'd build up from there. A $50 phone you assemble like Lego. It sounded like the future of hardware. But a slot for every part raises a hard question. What has to connect through all those gaps? Here's where it gets expensive. Physically expensive. Every slot needs to pass data, and fast. The first design tried to move that data without metal pins touching, using short-range signals between modules. It couldn't keep up, so the team switched to a wired standard called UniPro. Real electrical contacts on every module, just to hit acceptable speed. That fix exposed the deeper problem. A phone is a fight for space, and every gap you leave between tiles is space you can't use. Think about a normal phone. It's a sealed slab. One battery poured into every spare corner, parts soldered tight against each other, the aluminum body itself adding stiffness. Now cut that slab into 6 removable blocks. Each block needs its own wall, its own connector, its own little tolerance for sliding in and out. All those walls and gaps add up. The result is a phone that's thicker, heavier, and slower than a sealed phone that costs the same. This is the tax nobody put on the poster. You are not just paying for the modules. You are paying in millimeters and grams and battery life for the privilege of being able to remove them. Say it plainly, swappable fights physics. And the physics wasn't done collecting yet, because there was one gap the engineers simply could not close. Now the gap. Modules only work if they line up almost perfectly and don't leak radio noise into each other. Ara's own engineers admitted they couldn't hit those tolerances cheaply. The seams between tiles let antennas interfere, and closing that 2mm gap tightly enough would blow the budget. Then the magnets failed them. Remember those switchable magnets that were supposed to hold everything? In practice, they couldn't grip a module reliably as the phone was jostled, dropped, or heated in a pocket. So Google retreated. Out went the elegant magnets. In came ordinary latches and springs. Physical clips you push to release. And a clip is not a hot swap. That single change gutted the dream. If a module needs a mechanical latch and a careful realignment, you're not casually snapping parts on a bus anymore. Watch what happened to the promise. By the big public demo at Google's 2016 conference, the frame no longer let you swap the parts that actually make a phone faster. The processor, the memory, the display were now fixed into the frame for good. What you could still change were the extras. A camera here, a louder speaker there. The Upgrade Anything phone had quietly become an upgrade a few accessories phone. So the machine was compromised. But maybe the market would forgive it if anyone still wanted to build the modules. That covers the machine. Now the market. A modular phone is only worth building if lots of companies make modules for it. And no one showed up. Put yourself in a small camera maker's shoes. To design a module you need volume. A guarantee that millions of people will own the frame. But there was no shipping phone, so there was no volume, so there was no reason to build for it. No phone, no modules. No modules, no reason to buy the phone. The chicken and the egg starved each other. Then timing finished the job. Rewind to 2013 and phones broke, aged fast, felt worth upgrading piece by piece. By 2016, the ordinary flagship was cheap, thin, waterproof, and honestly good enough. The Ara was built to scratch, had mostly healed. Most people didn't want to assemble a phone from parts. They wanted one that worked out of the box. And the schedule showed the strain. The Puerto Rico pilot was quietly canceled. The ship date slid from 2015 to 2016 to a date that never came. When your launch keeps moving and your ecosystem never arrives, you're not building a product anymore. You're funding a very expensive demo. So what actually delivered the final blow? In September 2016, Google officially suspended Project Ara. Break time equals 0. 6 is slash no consumer phone had ever shipped. Here's the whole mechanism clicked together. Modularity isn't one feature you bolt on. It's a tax you pay everywhere at once. The very things that let you swap apart. The gaps, the connectors, the tolerances are the same things that make the phone thicker, heavier, slower, and more expensive than a sealed one at the same price. Ara didn't die from a single mistake. It died from a three-way collision. Physics sent the bill. That 2mm gap and the magnets that wouldn't hold. Economics sent its bill. No shipping phone meant no module makers, and no module makers meant no phone. And the market sent the last one. By 2016, sealed phones were so good that almost no one still wanted to upgrade one piece at a time. Given the choice, people pick the phone that just works. Every single time. That's the master loop closed. The paradox was baked into the promise from day one. So remember the shape of it. 6 swappable modules, a 2mm gap, and 0 phones ever shipped. But the idea didn't fully die with the frame. It just found humbler bodies. Fairphone builds a repairable phone you can actually buy today, and Framework does the same for laptops with parts you swap yourself. The dream shrank to fit the physics.